to a tutorial about stoichiometry, and this time we're going to include gas laws. Now, at this point, we should be able to go through what I call the 4 boxes. And in dealing with the 4 boxes, stoichiometry is really just the second to third box. It's literally just moving from moles of one thing into reaction to moles of the other, using whole numbers from the coefficients in a balanced equation. A, if you remember, is what's given. Any kind of information we're given is A. It could be a reactant or a product. B is what they're asking for, and it could be a reactant or a product. So if we're dealing with grams, which we do a lot because we weigh things on a scale, or liters of gas, which we do early in your year in chemistry, or particles, in which case we would use Avogadro's number, we could use the 4 boxes to go from one side to the other. We could start in the first and go to the last, or any kind of combination. And there's lots of combinations, so it's good just to have all these tools underneath our belt to be able to work with these things. The problem with the gas one, using 22.7 liters of space, it's only good at STP. And people get this really confused. STP is not 22.7 liters. STP is standard temperature, which is 0 degrees Celsius, and standard pressure, which is 100 kPa. This means this conversion of 22.7 is only good at 0 Celsius exactly and 100 kPa. If the temperature is different or if the pressure is different, then we can't use this. But what we can use is PVnRT. Now, PVnRT is the ideal gas law. It is a calculation using an ideal gas, which is defined by the kinetic theory of gases. But we assume that the gases are ideal and we can use this. You should know by now that R is a constant. If you use the R as 8.31, it has units of kilopascals and liters and moles and Kelvin. So if R equals to 8.31, and that means it's kilopascals, liter per mole, Kelvin, that means the temperature has to be Kelvin, but whenever we use temperature, it has to be Kelvin anyway. So we add 273. N represents moles. There's nothing else it can be. Volume, we could have all sorts of volume, but we need to have liters. It needs to be liters to fit. And pressure, it needs to be kilopascals if we're using 8.31. There's other R's we could use, 0.0821, and that's going to be for ATM, liters per mole, Kelvin. But IB specifically uses this one right here almost all the time. We could convert, it's easier, I think, to convert the pressures to a new pressure of kilopascals and use 8.31 than to memorize more and more R's. But just to be aware, AP gives you 3 R's. They give you these two plus 62.4, and that's going to be torr liters per mole Kelvin. So even though there's 3 R's that AP would give you, temperature is still Kelvin, moles are still moles, and volume are still liters. The only difference would be pressure. Whenever I teach stoichiometry, I always say if you get stuck, run home to mama, convert to moles. Well, if they give you a volume of gas, then you have to see if it's an STP or not. And volumes could be misleading. Problem, they could give you 45 milliliters of something, and you have to figure out what to use. If they give you 45 milliliters of something that's an aqueous solution, we're not going to use gas laws because it's not a gas. And typically in this, you would see molarity, or they would ask for molarity, which means we would use the equation for molarity, which we'll talk about later. If they give you 45 milliliters of a gas and it's at STP, we can convert the milliliters to liters and use 22.7. If, however, they give you a gas that's not at STP, we have to use PVnRT. We still have to convert the 45 milliliters to liters because we have to match the units. If you're given a gas that's not at STP, we just rearrange the equations and solve for moles. And once we solve for moles, we're going to be in the first box. And then we can go and answer the question. We can convert the moles of the gas to moles of whatever they're asking for, and then answer whatever question we get. if the stoichiometry question is asking for volume of a gas or asking for pressure of a gas, and it's not at STP, you do your stoichiometry, you find the moles of the gas that's not at STP, you drop out of the 4 boxes at that point, and then you rearrange the equation for PVnRT and solve for whatever the question asked for. So the moles would be the N right here. And so once we drop out of the 3rd box, we have moles. They should have given us temperature and pressure, and we can figure out volume, or they give us volume and temperature, and we can figure out pressure. A straight up stoichiometry problem, but using PVnRT as opposed to 22.7. They give us the mass of the propane, which is going to be 15 grams. And they're asking for the volume of carbon dioxide gas. However, you can see the temperature and the pressure. It could be either one. Is not under standard conditions, and therefore we need to use PVnRT. Well, sequencing these out is tough for some people. So you start with what you have and you go to the question. We have grams of propane. That's A. We're going to go to moles of propane, which is also A. And then we're going to go to moles of the question, which is going to be carbon dioxide, or B. And then we're going to stop there and drop out because this is dimensional analysis. And now that we have that, we're going to use the ideal gas law, and we're going to say V equals to nRT over P. We got to make sure that the units match. We'll plug and chug and come up with the answer. So here I've set up the problem, which we went from 15 grams of propane to moles of propane using the formula weight, which we get from the periodic table. And then we went from moles of propane to moles of carbon dioxide using the coefficients from the balanced equation. You can follow along through the 4 boxes. And at this point, we're going to drop out. So I got 1.02 moles of carbon dioxide. Now, that is kind of an answer to the first part of the problem. And now we're going to just use algebra and use the PVnRT because it's not at STP. So we have temperature is going to be 575. However, it needs to be in Kelvin, so we're going to add 273 to it. We get 848 Kelvin. The volume is the question, so we're just kind of using this guess method. The pressure is 98.2. We're going to have R equals to 8.31, and we're going to have N equal to 1.02 moles. So I'll start with the algebra equation of PV equals nRT. I isolate for the volume. It's on top. It's not by itself. The P goes over and down. So I get my new equation of nRT over P, and then I'll plug all the numbers in, and I get 73.2 liters carbon dioxide. And that is how you incorporate ideal gas law with stoichiometry.